Hi, welcome to Mat210 Elements of Calculus, and we're going to discuss this section 4.5, which deals with integration by a method called U subs or U substitution. And this is when calculus becomes a little bit tougher. Okay, so we're going to look at a problem here, and we're going to kind of recall how we went ahead and did derivatives. Okay, so let's say we have a function here, y equals x cubed. This is example 1 on page 437. And we're going to take the derivative of this because we've been doing, antiderivatives. So now it's, do we remember how to do derivatives? That's the question, you know. Sometimes we forget how to do that stuff. I'm going to move this down so I can, I don't know. It never gets very comfortable with this thing. Like that. Anyhow, the derivative of this, we're going to put derivative with respect to x, dy dx is, do you remember how we did this? We multiplied 3 times the coefficient, and then we subtracted 1 from the power. So the derivative of y is x cubed, 3x squared. If we wanted to do the integration of this problem, we have 3x squared dx. See, if I cross multiply here, or I multiply both sides by dx, then all of a sudden we have it in the antiderivative form, and that's where that dx comes from. Okay, maybe you were wondering what is this dx thing? Well, that's where it came from. It's the reverse of doing the derivative. So how would we do that? Let's see if we can remember. Okay, we could factor out the 3. So we have x squared dx. And then remember, we add, let's put the 3 here, we add 1 to the power, x cubed, and then we put it over 3. The dx goes away, plus c. These cancel out, and you see you end up with your x cubed plus c, the original problem. So it's the derivative and then the antiderivative. The antiderivative of the answer leads us back to the original problem. Okay, so that's kind of the theory of this whole thing. But we haven't still got into U subs yet. We're going to practice just a little bit more of doing derivatives, okay? So let's try another one here. We've got, let's call this U instead of Y. U equals x to the 2/3. This is example 2. So what would the derivative be? Du with respect to x, dx is 2/3 x. And then remember we subtracted 1, which would be 3/3. So that would be a negative 1/3, huh? So it'd be 2/3 x minus 1/3. Kind of just refreshing our memory about derivatives. What if we had u equals ln x? So the derivative of that would be du over dx is, do you remember the derivative of ln x? That's 1 over x plus c. What if we had e to the x? U equals e to the x. The derivative, du over dx, is equal to e to the x, remember? It's the same thing. Okay, what if we had something a little bit more challenging? What if we had u equals e to the x squared power? Okay, so du over dx, let's see, what would that be? Well, here we'd have to use chain rule. This is equal to e to the x squared times the derivative of x squared, 2x, chain rule. Or we could write it as 2x e to the x squared. You know, either way is okay. Plus c. No plus c. We're taking derivatives. So these are all your, how you take derivatives of a function, because we might be a little rusty on it. But what we're going to do is try to take the antiderivative of this problem. We're going to take the integration, write it down here, the integral of e to the x squared. I'm going to write it like this, 2x dx. So how do we do this problem backwards? You could say this one wasn't too bad to do backwards. It was a little hard. We had the 3x squared dx. We could factor out the 3, then we could take the x squared, get it as x cubed over 3, and then reduce it down. But what about this problem if we have to take the integral of it? You see, because this involved chain rule. So the first thing we're going to do is use a method called u subs. And we're going to substitute, we're going to replace some of these letters in here with the letter u. So we're going to let u equal. Now, what do we let u equal? It's kind of difficult to decide, but usually it's the term with the highest power. So we're going to let u equal x squared, just the power, x squared. And then we're going to take the derivative of that with respect to x. And the derivative of 2x is what? Of x squared is 2x, yeah. Okay, I kind of gave that one away. Now, what I want to do is I want to leave this as du. I want to get rid of this dx. So I'm going to multiply both sides by dx. That would cause this dx to cancel out. So du equals 2x dx. And you see right in this problem right here, we have a 2x dx. So I'm going to replace that with du. And where there's an x squared, this is still under the integral sign. In place of the u, the x squared I should say, I'm going to replace the x squared with a u. Now it's in a form that looks sort of like this problem right here, maybe, but it has just, instead of having x's, it has u's, okay? Everything inside here has to be accounted for. If you have a 2x dx, there has to be a replacement for it. That has to be the du. Wherever there's a dx, we're going to replace that with some kind of form of du. And wherever there's a variable, maybe a power or something or whatever, we're going to replace that with a u. Now, this becomes pretty easy to do because, remember, the derivative of e to the x is e to the x. So the antiderivative of e to the u is e to the u plus c. Now at this point, what we do is we replace u with x squared. And we get e to the x squared plus c. And this is the integration of e to the x squared 2x dx. It's e to the x squared plus c. So this is how we kind of handle something strange like this 2x because of the chain rule. And this is a little bit more difficult kind of problem to integrate. So we're handling it with a technique called u subs. And sometimes problems get even harder than this, so then we have to use another technique called parts. But right now we're going to work on u sub. as a technique. And I know when you first see this, it is kind of confusing. Let me take another problem here and we'll see if we can make some sense out of it. Okay, this is example 5 in your book. And you have this integration of 3x squared times the quantity x cubed plus 1 raised to the 10th dx. So the first thing I'm going to do is try to put the 3x squared, anything that's not in the parentheses, kind of together. So I'm going to write this as the integral of x cubed plus 1 to the 10th times 3x squared dx. So now the decision is what is going to be u. Well, u, if you usually go with the idea that u is going to be the expression that has the highest power, then we're going to let u equal x cubed plus 1. We're not going to worry about this exponent. Last time we used an exponent, but most of the time, if the exponent is just a number, we're not going to use the exponent. We have to use an expression. So u is going to be x cubed plus 1. Now we're going to take the derivative of that. And this is where the derivatives come in. So what's the derivative of x cubed plus 1? It's going to be 3, and then the power gets smaller, x squared. And the derivative of 1 is 0, okay? So it's 3x squared. Now, last time, remember, I multiplied by dx on both sides. Save a little bit of time. Sometimes we just cross multiply. So I'm going to put that dx up here. So now it's 3x squared dx. And we can see we have 3x squared dx. So in place of this, I'm replacing that with a du. Okay? And in place of the x cubed, I'm replacing that with just the symbol u. So this is u to the 10th du. Well, now we got to go back to antiderivative mode. We were in derivative. Now we got to think of integration mode. So now how do we do that? Well, remember on this, we're going to add 1 to the power and then put it over that number. So it's a little confusing because you're thinking derivatives, now you're thinking antiderivatives in the same problem. I understand that. And now we're going to substitute what is u. Go back to here. And we're going to replace this u with this expression. So it's going to be x cubed plus 1 to the 11 over 11 plus c. And that is the integration of this problem. Where you're saying, well, why couldn't I just do that and just ignore that? Well, sometimes you could, but sometimes you can't. So you have to be a little careful. It's not always as clear cut. Some of them get a little tougher. So we run into situations where it might be a little bit harder to do it. Maybe this next problem would explain that. Example 6, we have the integral 2x dx over 1 plus x squared. And we want to take the integration of that. First of all, we see this is a big fat mess, huh? Other than that, we try to figure it out. Okay, now in the book, sometimes they don't write this down. They have it in the instructions, but they don't really seem to write it down. But, but it's essential that you write this down. What does u stand for? Well, again, I'm going to go to the rule of the highest power. So I'm going to use this expression, 1 plus x squared. Then I'm going to take the derivative of that with respect to x, which is 0 plus 2x. So 2x, I'm going to bring my dx up here. And I notice in the problem, I have a 2x dx. So we can account for this part. In other words, we're taking that and we're going to write that as du. going to write my integral there. And 1 plus x squared, I'm going to write that as u, but that's in the denominator. So I'm going to write this as kind of like 1 over u. So what is the integral of 1 over u? The integral of 1 over u is the natural log of u. So this is equal to, now we're going to take it out of here. This is the natural log of u. And remember, the du kind of just goes away. Or you could think of it as a 1 times that. So that's why we have to get it into this form right here. So that this stands for the du, and this right here stands for the u. Okay, plus c. And then we can simplify that by saying, well, what is u? We go back to our instructions right here, and we see u is 1 plus x squared. We can put that in parentheses if we want, plus c. And there's our answer, see? And we've got this thing knocked out. So it's the natural log of 1 plus x squared plus c. So yeah, it is a little confusing. It's very confusing. So let's try one more, just kind of. Here we have 2x dx, almost the same problem. 1 plus x squared, almost the same problem, but now it's squared. A little variation on it. So what is u going to equal? U is going to equal the same thing. It's just going to be 1 plus x squared, not squared, but just 1 plus x squared. Okay, just like that. We usually don't raise it to another power. Okay, and du over dx is going to equal the derivative of that, which is 2x dx. So once again, we see 2x dx is equal to du. Let's put this. And this is going to be 1 over, and it's going to be u. But now it has a power on the outside, u squared. Well, 1 over u squared is not the natural log of u. That only works if this has a power of 1. There's a power 2. We have to move this up to the top. This would be u to the negative 2 du, the integral of that. And how do we integrate that? Remember, we add 1. So this is going to be u to the negative 1 over negative 1 plus c. Or we can move this back down to the bottom. This would be u to the positive 1. So this would be, now let's substitute in, what is u? 1 plus x squared. I'm going to move this negative 1 up to the top just to make it a little bit easier. This would be negative 1. I'm going to move this up. And this would be over u, which is 1 plus x squared du. Plus c. Where the du come in. And I can write it like that. Is that how they ended up writing it? Yeah. So I know you might have to play these over again, like rewind, and I know the first time I saw this, I'm going, this doesn't make any sense at all. Can they get worse? Yeah, they can get real worse. And this is one of them. X to the e x squared dx. Darn chain rule, huh? You can see there's a little chain rule in here. So that's why we got this mess here, because of the chain rule, and sometimes because of ABBA and BABS and all that stuff. So now we're going to kind of rewrite this. I'm going to rewrite it so it's a little bit easier. E to the x squared x dx. So we're probably going to replace this x dx with a u. You know, you kind of think it in your mind. So what are you going to let u equal? Well, our natural tendency is to say e to the x squared, but we just want it to be x squared, not e to the x squared, but just x squared. That way du over dx can be 2x. And we'll just put our dx up there. But everything has to match up. And you don't have a 2x. You have a x. But you need a 2x for this to work. So we have to use a little technique here to get rid of this 2. We don't want this 2 here. We have to get rid of it. So we're going to multiply this part of the problem by a half, because a half times 2 is going to eliminate it. It's going to make it 1. But then I have to multiply the other side by a half to balance it out. Now, I can do this with a number. If this is a 3, I can use a third. If this is a 4, I can use a fourth. But if it's just x and there's no x here, I can't use 1 over x. I cannot use 1 over a variable. I can use 1 over a number, but not a variable. So then we're stuck and have to learn another technique. But on this one, we can use the 1/2. So these canceled out, right? They're gone. So now I have the x dx. So I'm going to replace that with du. But what about this half? I'm going to put that in front of my integral like that. See? So now it's going to be 1/2. I got to account for that half. I'm not going to put a 2 here. I have to put a half because the half canceled out the 2. Okay? Now what about x squared? So this is all accounted for. It's du. This is going to be e to the u. What is the integration of e to the u? It's e to the u. But I have to bring down the half. 1/2 e to the u plus c. Or now getting it in terms of x, going back to x, substituting in, it's going to be 1/2 e to the x squared plus c. You see? So that changed the whole problem around, huh? And that's where this half comes in. And that's why you have to use a technique like u subs to solve this problem, where you wouldn't be able to, it'd be very hard to do it without u subs. So this is what we're doing. And a problem that's rather complicated, has more than one variable under this thing and all kinds of things. We're doing a derivative here and an integration here and a substitution. So there's 3 parts: differentiate, integrate, substitute. And it's not always the easiest. Okay. This next one is pretty easy. I'm not going to do that one, but I'm going to try this problem right here. Super hard one. Example 11. I have 5x times the square root of x squared plus 3 dx. What a mess, huh? Well, let's rewrite this as x squared plus 3 would be x squared plus 3 to the half power. And then let's write this as 5x dx. So let's simplify that a little bit. And I like to put this together because that's probably going to be our u and our du, and this is going to be kind of like involving the u. Well, what do you think we should set u equal to? I usually put u on this side. What do you think we should let u equal? See this okay? Maybe that's a little bit better. What can u equal? U could equal this x squared plus 3 without the power. So then what's du? Du is going to be 2x, just 2x, huh? 2x. And this would be over dx, dx. 2x dx. I don't have a 2x dx. I got a 5. So first, I want to take out this 5. I want to put this 5 in front. Remember, we can do that. I should have done that right away. I should have taken out the 5 right here, and I didn't think about it. But I I recognize it. But now I got this x dx, so I'm going to use the little half technique or fractional technique. I multiply this by a fraction. Half cancels out the 2. So now I have x dx, and that would be du. But I'm going to put the half in front with the 5. Okay, 5 halves, basically. And then in place of x squared plus 3, I'm going to put my u to the half power. What a mess, huh? So now I've got 5 halves times u to the what? Well, we're going to add, right? 2 2's. So that'll be to the 3 halves times the reciprocal of 3 halves, which is 2/3, plus c. Right? U to the 3 halves. And then remember, when we had a fraction, we used the reciprocal. So that would mean this would be 10/6, or we could reduce it a little bit. We can report those 2's would cancel, so it's 5/3 u. But what is u? U is x squared plus 3 to the 3 halves plus c. And now we've worked out this problem. Holy camole. Yeah, pretty hard little monster, huh? So here we had to take out the 5. I should have done that right away. And whenever you have a number, take it out. You know, it's just with an x. If it's not in a parentheses, if it's in a parentheses, then you can't do that. But take out that 5. We had to modify our derivative to 1/2 du. So I put the du here and the half here. 1/2 du, u to the half power. So this is the monster of the monsters. Well, there is one worse one, but that's kind of the monster of them all. You know, I know this is tough. This is not an easy problem right here. This is one of the harder problems that you're going to encounter. Let's try maybe one more like that. This, oh. Then on top of that, let's suppose, I forgot all about this, let's suppose they wanted us to evaluate this from 1 to 0. Yeah, then in this case, there wouldn't be a c, it would be from 1 to 0. So let's do an evaluation on this. We can use this for not only just basic integration, or we can use it for direct integration with actual numbers. What do we call that again? Definite integrals. Definite integrals. So let's put the 1 in here. This would be 5/3 times 1 squared plus 3. I just write the whole thing down to the 3 halves. Yikes. Minus 5/3 times 0 squared plus 3 to the 3 halves. Okay, or you could put the 5/3 separate. It really doesn't matter. Sometimes they just put instead of writing it like that, they sometimes put the 5/3 around the whole thing. But technically, it means 5/3 times each part. So I'm going to write it on both parts. Okay, so let's see what this is. 1 squared is 1 plus 3 is 4. So I got 4 to the 3 halves. What is 4 to the 3 halves? I'm going to jot it down here. 4 to the 3 halves is 4 to the 3rd power. It's really the square root of 4 to the 3rd power. Power over index. So that's the square root of 64. So it's 5/3 times the square root of 64, which is 8. Minus 5/3 times 0 plus 3 to the 3 halves. 3 to the 3 halves is the square root of 27, which unfortunately is not a real nice square root. 5/3 times. So let's find out what the square root of 27 is. Second x squared, excuse me, 27. Equals 5.2, which is called 5.2, close enough. So I got 40/3, take away 5 times 5.2, 26/3 equals 14/3, 3 and the 14. I might have done this a little different from the book. 4.67 is what I come up with. And I think the book came up with 4.673, but I come up with 4.666. Okay. So we could have actually evaluate that. It takes a little bit of work, but it can be done. You know, and you could do it different ways. You know, you could have subtracted this and then multiplied it by 5/3 or whatever. Okay, one last one because we're running out of time here. Kind of a goofy problem. This one's a super deluxe. It doesn't look that hard, but it is. So we're trying to solve this thing. What would you think u would equal? Let's try this again. Let's put our u here. What would you think u would equal? X plus 2. So what's du over dx? Du over dx, let's see the derivative. That would be 1 plus 0. So that would be 1 dx. See? But the problem is I've got an x here. And remember, I said I can't multiply like 1 over x or something like that. Or I can't multiply an x times both sides. So I'm kind of stuck. I know this is going to be, this was x dx. So I can see this is going to be something like 1 over u, but I don't have an x dx. So what I'm going to do is I'm going to look at this part of the problem again. If u equals x plus 2, x would equal, let's bring this 2 over to the other side, u minus 2. So now I'm going to substitute in u minus 2. And this, and in place of dx, I'm going to put du. Okay, so now that's my problem. 1 over u minus 2 du. So now we're going to try to take the integration of that, but that's a little hard to do. So what I'm going to do is I'm going to put this, distribute this 1 over u to this. And that's going to give me u over u, which is 1 minus 2 over u du. Okay, so now I'm going to integrate this. The integration of 1 is just, and we're going to do it in terms of u. The integration of 1, what would be the integration of 1? That would be just u minus 2 over the natural log of u plus c. So that would be the integration, but what does u stand for? Going back here, x plus 2, that quantity, you could put it in the parentheses, minus 2 over the natural log of u, which is the natural log of x plus 2 plus c. That would be my answer. At least that's what I came up with. It was a little different from the book. They got the x plus 2. Something's not jiving. Let's see. Wait a second. I made a mistake here. U is x plus 2, right? Minus 2. And it's not over. It's 2 natural log of u, which is x plus 2 plus c. There we go. Now, I notice in the book they have an x minus 2. They have the x plus 2 minus 2, x plus 2, natural log of 2. How do they come up with an x minus 2? They have this, and then the next step is just x minus 2. Reversing the substitution. Not exactly sure how they got to their final answer. I don't want to spend too much time in here, but this was kind of like u minus 2, which was x. I'm going to leave it like this, x plus 2 minus 2 natural log of x plus 2, because you really can't subtract these two numbers. I'm not exactly sure how they ended up with an x minus 2 natural log of 2. Somehow they get, and I'm thinking they're going back to something up here, but I'm not exactly sure what they did. So I'm going to have to analyze that a little bit, and I don't want to waste any more time. Okay, so I know this is a tough one. I don't think you have any problems like this. I just kind of showing it to you, and I should have reviewed it more myself. Let's do one quick one and see if we can do it. Let's say we had this problem right here. X cubed dx. This is number 39 over 2 minus x to the 4th raised to the 7th. So I'm going to let u equal kind of that 2 minus x to the 4th. It sounds like a reasonable thing. Du over dx would be, this become a 0. This would be a minus x to the 4x to the 3rd over 3. Right. No. Just minus 4x to the 3rd, because we want to, it's hard enough. Come on, let's not make it any harder. Need to get rid of the negative 4, right? So I'm going to multiply this by a negative 1/4. And that'll get rid of that 4. So now it's going to be in the form, in place of the x cubed right here, I'm going to put negative 1/4 du, negative 1/4 du. And I forgot to put my dx on the top, and that's what's throwing me off, dx. Okay, so x cubed dx is negative 1/4 du. So the du goes over here. And then this is 1 over u to the 7th, like that. Okay, so let's rewrite that as negative 1/4 u to the negative 7 du. And that's going to, remember, we're going to add 1. So that'd be u to the negative 6 over negative 6 times the negative 1/4 du plus c. Okay, so that's the integration of that. And that again, negative 1/4 times negative 6, let's put the negative on the bottom. So that'll give me 24. So, and we could even bring this down if we wanted to. This would be 2 minus x to the 4th to the 6th power, 1 over that, plus c. Let's see if we ended up with the right answer. And of course, they usually don't have the problem. I pick 39, 1 over 24, 2 minus x to the 4th to the 6th plus c. That is the correct answer. So this is the correct answer to this problem. So you have to mess around with it. You have to do a derivative, antiderivative, substitution, a whole mess. U subs. Enjoy.